All right. Now, last week, I talked about exponential function, and we started looking at e. And we know that e is this number. All right? It's the Euler's number, and it's 2.7182. All right? So what you've got to treat it is like any number. It's just like pi. It's just an irrational number. But it's used quite a lot in terms of practical problem. Talking about decay and also growth. Right? We know that if y equals a times e to the power of bx, dy dx is actually ab e to the power of bx, correct? Yeah? So now we're going to think about a practical situation where we've got an initial starting value. So after today, you should be able to apply the exponential function to the context of continuous and natural growth and decay. Solve problems involving the rate of change, and then use the exponential function, y equals y naught e to the power of kx, or I've written there, y equals p naught e to the power of kx, as the general solution to any differential equation dy dx equals ky. I will explain that a little bit more. Alright? Now, this is what you need to know: your product rule, your quotient rule, your chain rule, and this is all in your formula sheet. So d dx of e to the power of ax minus b is a e to the power of ax minus b. Now, let's start to have a look at this general slide. Talk about the Euler's formula E. It's derived from a situation involving continuous exponential growth or decay. For example, if growth is y equals e to the power of x, whereas decay is y equals to e to the power of minus x. We can actually model many situations mathematically using the exponential function when growth or decay is occurring continuously, such as in economics, natures, and physical science. All right, you should know how to plot that on your class pad, so I'm not really going to go through that. So realize that you could model situation in terms of growth and decay using E. That's the important thing. Now, let's think about the general exponential function. We've got a situation involving continuous exponential growth or decay. It can be modeled by using P equals to P naught e to the power of kt, where P naught is the initial value. All right? P naught is the initial value of P. That is when time equals to t. So remember, if you need to look for the initial value, set t to 0. If you set t to 0, what happened? E to the power of 0 is 1. Therefore, p is p naught, correct? Yeah? So when this is 1, p naught equals to p naught. Now, k here is the constant rate. Think about whether it's growth or decay. If it is greater than 0, it's the growth. Less than 0 is decay. All right, not decal, DKDs. All right, so if you think about that, P naught gives you the initial value. K tells you whether it's decay or growth. Now let's start looking at example 1 straight away. All right, $2,000 is invested at a rate of 6.2% compounded continuously. The amount A after t years is modeled by the equation. This equation is given. Determine the amount in the investment after 2 years to the nearest dollars, and then the time taken for the investment to amount to $5,000. You don't even have to use your compound interest formula. You can just straight away use E. All right, and that is your interest rate, 6.2%, 0.062 times t. So substitute t as 2 in this situation. Just use the formula given. Don't think about compound interest formula anymore. Just use whatever is given to you. And then you should be able to determine the time taken for the investment to amount to $5,000 to the nearest year. All right? So part A, substitute t equals to 2, work on it please. And then part B, you should be able to use your class pad and use solve.
Oh, why is my class pad taking a pen?
Those are the two things you need to do.
My pad is dying, so.
So you got A. A is pretty straightforward. Substituting T equals
It won't
2.
work.
If you ever got a class back, I'll lend you one.
It just won't run it.
180x.
Yeah,
60 times 3, yeah.
They just won't get it.
Anyone without a class back?
What'd you get? Can you just tell me your answer?
Part
Look at this.
B, you really need to use your
17 something.
class back to solve.
Just solve.
What?
Just solve. Pretty easy. It just means
Bro, my class
that you differentiate.
Class back. Don't use your. Please don't use
Means
your
like DY. Just
scientific
means
calculator.
like
Use
X
your
on the
class
bottom,
back
so DIDX.
because you got to solve it. The next week you got to when you solve it, you always have to use your class back.
Yep, just normal.
Get used to your class back, especially for the exam.
No. Actually,
Oh my god, sir, my class
yeah, it doesn't say, so maybe we simplify a bit. Maybe.
All right.
Actually, I think that's fine.
So if t equals to 2, substitute a, and you need to give it to the nearest dollars, which is 2264.
Wait,
Alright?
what's the first
I
question?
should have written down there to 2264. Nearest dollar.
My class bed just doesn't move.
Now the next one, think about substituting $5,000 into here and use your solve function in your class back. And it's approximately 15 years. All right? You need to be able to use your solve function in the class back. Do you all agree with my answer? Do you get the same thing? Did you use the solve function? So you really must be able to use your class back to your advantage. All right?
My god, brother.
That's the most important thing.
My class bed doesn't work.
All right, let's think about example 2. I've highlighted the word initial there. So initial means t equals to 0, correct? So the voltage between the plate of a discharging capacitor can be modeled by the function Vt equals to 14 e to the power of kT, where V is the voltage in volts and T is the time in seconds and K is a constant. It was observed that after 3 minutes the voltage between the plates has decreased to 0.6 volts. Now important, this is 3 minutes and the time is in seconds. Highlight that please. So I'm going to show you, this is what I would do because I really want to know, I know that T here is in seconds. Alright? Whereas this one is 3 minutes. So you must make sure that you know your units. Those are how, these sort of questions, this is how they catch you in the exam. If you don't read the question carefully. So you must be able to change your seconds into, change your minutes into seconds. So the initial voltage between the plates is when T equals 0.
60 times 3. You said 3.75.
Now, we did not say, it did not say in the question whether it's 2 decimal places or 3. Generally, just give it to 2 decimal places. All right? Now, from example 2, I'm going to lead you to another concept. Working of initial voltage when T equals 0 is 14. Don't worry about K at that stage. You don't need to know K yet. You just need to be able to find out V0. how do you actually determine the value of k? Solve. Yeah, I know you use a solve function, but you must use the other information. After 3 minutes, the voltage between the plate has decreased to 0.6. So V3 times 60 is 180, correct? V180 equals to 0.6, not V3, all right? So, yeah.
Did you get a negative?
Yeah, of course. Yeah. What's wrong with it? It's a decay. See that after 3 minutes it's decay, hasn't it? So it is decay. It is correct. See, that's why. Use class best. So it is decay. Now, in this situation, I actually use 3. For k, I would use 4 decimal places. Or, if you actually use your class pad, you can just copy and paste everything. Alright? So see, what you have done is you must make sure that VD determine the value of k. So use V 180 equals to 0.6. Alright? Note the unit. Change minutes. Rule seconds. Alright, you need to change in minutes to seconds. Then you can find your k. Yeah, you can use solve to do that, and then you should be able to find k equals minus 0.0175. Now, so the next bit, you know that half is 7. 7 is, VT is 7. You need to find what T is. So I worked out T is approximately 3.61. Oops, I forgot to write down T. Right. Now you can use your class pad and put the whole lot of number of k in if you use your class pad. I want you to look at part D and think about how I'm going to relate
Second derivative.
this dp dt or dp dx in terms of p. Alright? How do I relate the first derivative back to the original equation? So here, if you look at this, after part D, you should think, how am I going to relate this P into that equation?
213. What do you get?
Negative 0.14. Let's see. So you solve the
rounding,
time.
maybe?
Now, first, what you need to do is think about
No, it's because I subbed in 8. I'm sorry.
your
For T.
derivative. Alright? And then substituting 8 into that equation.
Yeah, there you go.
Now,
That's the most
see this
mistake ever.
here.
Yeah, no, that's right.
I've highlighted this and make an arrow to here. Think about what I've done there. What have I done in terms of that and this bit? What is that? In that highlighted thing.
That's the old equation.
Yes, the original equation, isn't that right? Alright, so you can work this out first. Think about that. I'm going to bring it
Jesus, times
to
about
what we are
that. Oh my
talking
God,
about.
Sir,
Yeah. Yep.
you got to solve for when it reaches 8 volts first, and then sub in the time to the first derivative.
Sorry?
Yeah, you need to solve for when 8 volts
No,
first, when it gets to 8 volts, and then you sub in the time.
no, because he's done it.
No, I've done it.
Because look, yeah.
You don't have to.
Because
See
he's
what this is.
subbed it in.
this is already 8.
Because that will equal
That
to
is
8,
already
right?
equals to the original VT. Right?
Yeah.
Yeah?
Wait,
That is, think about that, that's why I highlighted that. What happened? What is that? Do I need to think about
14e
solving
to
t
negative
b first?
0.0175 times 39.
So that is
Or whatever
already,
it is, times 35.
sorry,
equal to
my,
8. So you can just times it by 8.
see,
yeah.
forget about
That's
that.
smart.
That is already what happened to that. That is the same as 14e to the power of minus 5, whatever it is, 175t. Correct? Yeah?
Yeah.
That itself is already VT,
Wow. I'm so amazed
which
by
is,
that.
you can substitute that. Yeah?
Oh.
Got it?
Yeah.
It will be a little bit clearer after the next slide. Alright? So I don't need, actually even have to solve it, I just substitute it in. Think about it, because let's have a look at the next slide. Right, the voltage was decreasing. Now, minus 14, which means it's decreasing at 0.1 volt.
Do we have to write that down? Do we have to say the voltage is...
Yeah.
At what rate? No, you don't have to.
Okay.
Although if you just give the answer as minus 1, 0.14 V, it's double negative. Do you know what I mean?
Yeah.
So you should do that. Now let's consider this general equation. Can you actually write the simplified expression for the rate of change of P with respect to T in terms of P? Do the first derivative of P
KP.
first.
It's KP. KP.
Do the first derivative of P first. So dP dt, what is dP dt? What is dP dt? Think about that. And then how does it relate to P?
Which was negative 0.14. Is that the right answer for the last question?
Yeah. It's still the right answer.
You need to, the focus question is, can you generalize the rate of change of an exponential model? Alright? The exponential model in terms of
Wow.
this, how do you
KP.
generalize
KP.
the rate of change?
That is legendary, so. That is actually insane, bro.
How do you do question 4? Because it
Alright.
says proportional.
Now, you know
But you
dP
don't
dt
have
is
the factor.
K times P naught E KT.
Look.
Correct?
I haven't
Now
read
look
about
at
question
this.
3 yet, so.
What actually is this? What is this?
That's P.
That's P. So,
P.
the rate of change is dP dt is K times P naught e to the power of KT, which means it's K times P. That's all. So with the rate of change, last bit just now, I just substitute P straight in. Right? I don't even have to evaluate P. Yeah?
Yeah.
So think about this. This is important.
okay.
This is,
Never
I
mind.
think, this
Question
is in
3
your
is
formula
very
sheet.
easy.
dP dt equals K times Kp. So as soon as you know what K is, you can substitute in there. What K is that? If you're given dP dt equals to Kp, you can substitute K into that equation. So there, we can therefore say that the rate of change of variable P at any instant of time is proportional to the value of P at that time given by a factor of K. Alright. This is the important thing. So identifying what K is,
0.32.
Yep.
Yeah,
what the
okay.
constant is.
So we're on the right track.
So don't get 87.8.
Yeah.
It makes life a little bit easier.
Oh, yes.
Alright, 2 more examples to go. Happy with that? Let's go on to the next one. Alright, let's start. Given that dn dt equals to 0.3n, determine an expression for n in terms of t if n equals to 2000 when t equals to 0. Now what is k in this situation? 0.3. Straight away, identify this. If you're given dn dt, straight away identify this as k. Alright?
What'd you get for
So once you identify that as k, you can just write out nt is n naught e to the power of 0.3t.
Wow.
And then work out when t equals to 0, what is it? When t equals to 0, that's 1, that's 2000, so n naught is 2000. Alright? So n naught equals to 2000, that's all. Now, can you try part B, please?
Easy, light work.
This time, you are not given t equals to 0, but you're given when t equals to 6. And think about what k is. What is k for part B? Sorry? Thank you. Negative quarter. So sometimes you might want to use 0.25, sometimes you might want to use a quarter.
Isn't it just
It's up to you.
0.6?
Sorry?
Isn't it 0.6
What's this for? B.
for 4? Like the number.
For 4A.
Yeah. Well, like,
No, it's a model.
Yeah.
No, 4B. I haven't done it yet, but it's easy.
Identifying
It's
k,
written
you know
weirdly.
that k
wait,
is
what did you get for A? A is equal to
minus 1000.
1000.
1000.
E 0.47T.
0.47. How's it 0.47?
Well, because you know the initial value, right?
So once
So
you've
you
done
put the
that,
initial value in front.
you could just write it down. AT
E
equals A naught equals to
XT,
e to the power minus
because
t
this is
over
the
4.
factor.
If you want to use minus 0.25, that's fine. Because you're using your calculator, it could be, it depends. It really doesn't matter whether you want to use decimal or whether you want to use decimal or whatever you call it, either decimal or fraction. Really doesn't matter. Using fraction, it might make it a little bit neater in terms of the equation, but not an issue at all. Alright, so if you could substitute, you know that when t is 6, a is 8. So that's what I do, and then I should be able to work out what t is.
Yeah, so. Oh, wait. Yeah, you can actually do it either way. Really? But I think.
T is 6, alright? This is 6.
Easier. So you equal them, then you.
Alright? So
Yeah.
therefore,
You can only, and you can only
I work out
do
a
one
naught
and
equals to
different
35.85,
the point.
2 decimal places, and you should be able to work out the expression. All happy with that?
Yeah, I would equal these two.
Yes.
They're much
Agree?
easier than these.
If you agree, let's go to the last example. The last example, I think.
I just agree
Yep,
with
that's the
that.
last example. Yep.
Sorry. Question 4 is a bit.
So the rate of increase, you're already given the rate of increase. So you know that it's not decay, this is a growth, rate of increase. If you read the question carefully, you know that k cannot be negative.
What'd you get for B? Did you get
I didn't do it because it's just like. sub points and shit.
21,150?
Now you're given the
Probably,
initial
because
number
you're
of
supposed to do
bacteria
it
is
like the way that he
1,000,
did
and
it.
after 1 day,
I
the
think.
number is 1,600. So,
That doesn't
you
sound
know
right for
t
me.
is in terms of day.
Because it's Tage's rate of kind of growth rate. Oh, maybe. That means the gradient is 21,000.
Right?
That doesn't sound right.
So you know that this is when t equals to 0,
Let me do it.
and this is
Solve
when
it first.
t equals to 1.
Did you do this?
So you should
And you
be
get
able to
T.
derive a model for the
No, I did it
population
the
of
way that he
bacteria
wanted to
P.
do it. Like,
T days
every
after the
derivative.
initial observation, and
And then
hence
that's 0.47
determine
K.
the number of bacteria to the nearest
So
100
the population is
after 1
4,500
week.
and it's
So 1
0.47.
week, T is equal to 7.
Wait, 0.47.
That's the number.
He,
So you need to think about how to derive K and how to derive, you
Yeah,
know
4,500.
the initial number anyway.
Yeah, it's good.
So use the information, find K. How would you find K?
You sub it into the equation.
How would you find K?
1600 is equal to 1000 e to the x to the 1.
Thank you. So you know that PT or NT is 1000 e to the power of KT, correct? So when T is equal to 1, you got 1600. So therefore you need to work, you can work out K equal to 0.470. And that is your expression. So work out, oh, I forgot to work out P7. Right, let me work that one out. And try to work out the next one, please.
Yeah, see, so get something to one of the differentiations, and then you get the gradient, and then you just use y equals mx plus c, and then you get
Alright, 2680.
y value equals.
So now if you could work out the first derivative, you should be able to work out
Yeah.
it's 21150 bacteria per day. Alright?
Yeah, so you put it into numbers to get the y, and then you can use it for y equals mx plus c, because you're going to solve this.
So you should be able to work out the rate of change. Alright, this is what I have for you today. Just quickly have a look at this is what you will have in your waste formula sheet. So if P equals to P naught e to the power of KT, dP dt equals to Kp. Alright? I'm going to stop here.